Greetings everyone. Well, welcome to our channel, College Course Solutions Mathematics, and let's get started. So today we are gonna be looking at excess 3 codes, and we are gonna be also looking at BCD addition rules and some examples on the additions. So mainly we want to start by showing you how we find the excess 3 code, and mainly it is found from the BCD. So you can see here I have described for you how we actually get the BCD and the excess 3 code, and of course we have done another video on binary codes which explains further on how we find the BCD. BCD simply means binary codes. Of course you can check it out. The link is in the description below. And so let's start with how you find the excess 3 codes. So you can see coming from decimal, we use a formation of 8421 to find the BCD or the binary codes. And then in order to find the excess 3 codes, we just add 3. And 3 basically in BCD is just 0, 0, 1, 1. So in short, we just add the 3 bits. So is in any BCD that you want to convert into excess 3 codes, you just have to add the 3 bits actually. So you just have to add 0, 0, 1, 1 to the BC binary code that you want to convert into excess 3. I have done some examples here. You can see, like, let's take an example in a decimal of 0, where the BCD is 0, 0, 0. So in order to get the excess 3 code, you just take 0, 0, 0 plus the 3 bits, which are 0, 1, 0, 1, 1. You can see here I have already calculated them in binary codes for 3. So you just add these two to the binary. So you will get for 0 is 0, 0, 1, 1. That's the excess 3 code for 0. And for 1, you just take 0, 0, 0, 1. Of course, if you don't understand how we find the binary code, the BCD, as I have said before, I would recommend you check that video out on actually binary codes. The link will be in the description. So you just take for 1, 0, 0, 0, 1, and you add 0, 0, 1, 1. Of course, you get 0, 1, 0, 0. I hope you understand on binary addition rules, where I have done another video for you. The link will also be in the description. So you will get 0, 1, 1, 0, 0, and for 2 you will take 0, 0, 1, 0, and you will just add 0, 0, 1, 1. You can see for 0 I had already done it here. So this is how you add. And now for 1, you can see according to addition rule, binary addition rules, 1 plus 1, it becomes 0, 1. So this 1 plus this one again is 0, 1. Then 1 plus 0, of course, is 1, and 0 plus 0, it will be 0. So that's how we found the excess 3 code for 1. And then for 2, we just add this with this, and we found 0, 1, 0, 1. And for 3, we just take 0, 0, 1, 1 plus 0, 0, 1, 1. We get 0, 1, 1, 0. That's how we find the excess 3 codes. And now let's look at the BCD additions rule. So basically there are just 3 of them. So the first rule says if the sum in which you have found after adding the BCD is less or is equals to 9, where the final carry is 0, then that answer is correct. Just the way it is, you don't do anything about it, you just write it the way it is. But of course, when you add the binary, the BCDs, you want to note that you always give your answers in decimal. You can see here it is always marked in decimals. So whenever you add and the sum is less or is equals to 9 and there is no final carry, basically final carry is equals to 0 just means there is no final carry, then that answer is correct. But if the sum is less or is equals to 9, where the final carry is 1, then that answer is incorrect. And in order to make it correct, you have to add 6. And it's not just 6 as a number, but you have to add 6 bits, which are the binary codes, which are 0, 1, 1, 0, in order to get the correct answer. And then the third rule says if the sum is greater than 9, where there is no final carry or the final carry is equals to 0, then that answer is incorrect. And you have to add again 6 to make it to get the correct answer. So I will be taking 2 examples where they are indifferent. They will be covering the 2 main rules. For the third one, I think for the no, it will be covering the first one and the third one. For the second one, it is just the same. So okay, so let's take the first question. You are being told to add 3 in decimal plus 4 in decimal. So when you're told to add this, of course it's BCD addition. You want to find, first of all, start by finding the BCD. Of course, for 4 is 0, 1, 0, 0. Of course, I have explained there in another video on binary codes. Here we use a formation of 8, 4, 2, 1. So we just put a 1 where there is a 4 in the formation and zeros on the rest. So for 3, then it's 0, 0, 1, 1. Of course, where the numbers in the formation add up to 3, we put 1s and zeros on the rest. So then we come here and take 0, 0, 1, 1 for 3, plus 0, 1, 0, 0 for 4, and we just add them, where we get 0, 1, 1, 1. Of course, when you write the formation, it will be 4 plus 2 plus 1, which means it is equals to 7, which means the answer is less than 9, and there is no final carry, which means the answer is correct just the way it is. So you just have to count from 0 in order to acquire the powers 0, or you can, of course, when you add is 4 plus 2 plus 1 is equals to 7, which is in decimals. Or the other method, in order to get 7, you just have to count the powers, which will be 0, 1, 2, and just have to come here and say it will be 1 times 2 is to power 2 plus 1 times 2 is to power 1 plus 1 times 2 is to power 0, where you will just get 7 as your final answer. So for the second question, you are being told to add 57, which is in decimal, plus 26. So as I have said, you just have to acquire the BCD or binary codes for 57, which you just start by acquiring for 5, which will be 0, 1, 0, 1, and then for 7, which will be 0, 1, 1, 1, and for 26 will be 0, for 2 of course will be 0, 0, 1, 0, and then for 6 will be 0, 1, 1, 0. Then you just have to come here and add them. Of course, with applying the binary addition rules, you will find that here will be 0 like that. After adding, you will get a number that looks like this. Of course, by the looks of it, this is greater than 9, and of course there is no final carry, which means it actually applies to the third rule, where you just have to add 6, which is 0, 0, 1, 1, 0, which after you add, you will get 1, 0, 0, 0, 0, 1, 1. And of course I have shown you the other method to convert where of course here you cannot use the formation since the number of first the 4 bits. So you just have to come and count. You will have 0. Of course here it will be 1 times 2 is to power 0, and then 1 times 2 is to power 1. You want to assume the 0 since any number multiplied by 0 is equal to 0. And here after counting you will get 0, 1, 2, 3, 4, 5, 6, 7, which means it will be 1 times 2 is to power 7. Add all the numbers, it will be 128 plus 2 plus 1, which is equals to 131 into base 10. So that's all for today. I hope you understood. I will just recommend that you watch the videos I have recommended for you in order to understand more. And don't forget to subscribe and hit the bell icon so that you may get notified whenever we post more mathematical solutions. Thank you.